This is video number 2, and I'll post this one. So, Audney and Amy, are you all right with that? It's annoying. Yeah, exactly. All right, Amy, I do apologize. I don't think I talked about that in class, but there was enough complications going on at the time. But if it's a concentrated solution, you get the chloride. If it's a dilute solution, you get this one. Yeah, I should have said, but I didn't, and that's totally my fault. All right, but that's why we do revision, eh? All right, how about this one? Copy this one and stick this one up. This one is well, it's not hard. None of them are hard if you know what's going on, but they can be quite awkward. Okay, so now we're looking at lead bromides. And let me make it bigger. What's the answer there then? Anyone? Do we have one there? Anyone at all? Anyone want to guess? Micah thinks it's C. Okay. First of all, I can't do these without writing them down. I'm sure you're the same. Okay, so we've got lead 2, PB, Br2. Gosh, look at the lag. It's taking forever, isn't it? PbBr2. Gosh, it's awful, isn't it? Br. Why is it doing this? It never used to do this. PbBr2. And what ions are in PbR2? There are Pb2 plus ions. If this is ever going to show, what on earth is this so awful? Pb2 plus ions and Br minus ions. I wonder if it's it might just be the internet. All right, Br minus ions. Now, these are going to gain 2 electrons, aren't they? And these are going to lose electrons. So, the lead ions are gaining, they're going to be reduced. And the bromide ions are going to be oxidized. But as you can see, my pen isn't working because it's so slow. It's so laggy. Right, I wonder why. Let's have a look at something. No, it's not working up there either. Right, so there you go. One's going to be reduced. So lead ions move to the anode where they're oxidized. They don't, do they? The lead ions move to the cathode. So that's wrong. Lead ions move to the cathode and are reduced. Yes, that is right. They go to the cathode and you take electrons. Sorry, you give them electrons, which is reduction. Bromide ions move to the anode and are oxidized. That looks right to me. And bromide ions move to the cathode. They don't move to the cathode, they move to the anode. So that's wrong. So the answer here is 2 and 3. So well done, everyone. The answer is C. Good for you. Okay. Now, another one. Well done. Yes, Audney. Very good. Right. So now, what about this one? If it ever pastes on. Oh, there we are. Now, let's have a look. Oh, look at this. Let's move this over here. See if anyone gets this one. Okay. Aqueous copper sulfate is electrolyzed using carbon electrodes. Which statement is correct? Now, this is one of the odd ones when we have electrolysis of, what are we doing? Copper sulfate. So here we're electrolyzing copper sulfate. Now, what's in copper sulfate? Copper ions and sulfate ions. They're the two they're the 2 ions in copper sulfate. You've also got hydrogen ions and OH minus ions from the water. Okay. Now, which one of these 2 go? Which ones get discharged? The copper ions or the hydrogen ions? Well, you have to look at which one is lower in the reactivity series. Copper is lower, so this will get discharged. Okay. So well done, Audney. Copper gets discharged. and it's going to get discharged like this. Copper 2 plus 2 electrons gives you copper. Okay, that's going to go there. Now, which is going to get discharged out of these two, the sulfate or the hydroxide? Anyone? My pen seems to have given up. Oh, there you go. Out of these two, what one you're going to get? Anyone? You're probably typing, but it's not coming through. Is it just my internet? It's just atrocious. OH minus are going to get discharged here because there's no halide ion there. So I'm going to put a cross through that one, and I'm going to discharge this. There's 4 of those. Gives me 2 waters plus O2 plus 4 electrons. That's awful, isn't it? No one can see anything. You know what? It never used to be like that. We haven't got that many people online. I really don't know why it's like this. Anyway, so let's have a look. Which statement is correct? Bubbles of hydrogen are formed at the anode. No, hydrogen isn't discharged here, so that's wrong. Bubbles of oxygen gas are formed at the cathode. No, oxygen, the OH minus, is going to go to the anode, so that's wrong. Copper is deposited at the anode. No, that's not true. Copper is going to go to the cathode, so that's wrong. And the blue color of the solution fades. That is correct, because we're reducing the number of copper ions to copper metal, and the copper ions is the thing that gives us the blue color. So if you got D, well done. Okay, I'm very impressed. Okay, here we go. Another one. We just have to fight through this horrible internet. All right. We're doing okay, but it's just a pain. It really is. So, anyone? I can't even move. Oh, look at that. I can't even move this yet. Let's put it there. Move it up there. Okay, make it a bit bigger. What's the answer there, anyone? Reaction at the cathode, product at the anode. Anyone? Let me try, while you're messing around, let me see. I'm going to check my internet speed, because it can't be as bad as this, surely. Right, let's try it. Ookla. I think we all use Ookla, don't we? Ookla, speed test by Ookla. See how, if it is my internet that's messing me around. You continue, right, I'm going to go. Gosh, even the Ookla page is slow. Anyone got an answer to this while I'm waiting for my Ookla? My word, it's not even there. Right, why is it so slow? You know what, I don't think even my speed test thinks I'm connected to the internet. That's how slow it is. All right. Anywho, anyone got an answer for this one? Anyone at all? Isn't that awful? I can't even do a speed test. The internet is so slow here. Oh. Here we go. Well, it says it's 10 megs a second, which is okay. I don't know what's going on. Right, anyone got the answer to this while we're here? B, Aldney thinks it's B. Let's have a look. Dilute aqueous sodium chloride. Reaction at the cathode. Yeah, is that good? At the cathode, yeah, that is going to be correct, isn't it? Yes? You are going to get hydrogen at the cathode. But at the anode, yeah, I think you're going to get oxygen. Why are you going to get oxygen? Because it's dilute, if you remember. Concentrated HCl, yes, you're going to get that at the cathode and you're going to get chlorine. So I think that's right. This is quite a nice question, if I'm right. Molten aluminium oxide at the cathode, no. You get the aluminium at the cathode and product at the anode is oxygen. So that's wrong. Concentrated sodium bromide, no. You'll never get sodium, all right? And you will get bromine there, but you won't get sodium. You'll always, because it's still aqueous, you'll get hydrogen. You'll never get sodium. All right, so it's 1 and 2. So the answer is A. So what did we think? We thought B, 1 and 4. No, you'll never get sodium, dear, at the cathode. If you look at concentrated sodium bromide, it's sodium ions and bromide ions and hydrogen ions and OH minus ions. Now the ions that are going to go are going to be, if this works ever, you're going to get you're going to get hydrogen going. My pen is useless. And you're going to get the bromide going. So you're going to end up with sodium hydroxide, as we often do. All right, so I'm sorry about that. The answer is A. Let's go to the next one. This one is quite easy, I think, but we got to do it. And there we go. Again, I can't move this down. All right, let's move this up. Make this central. And make it bigger. Anyone want to give an answer to this one? Okay, or no, whatever. Rubidium's in group 1. What's the answer here? Anyone here? A. This is, you've got to read this carefully, this one. All right, this is not really electrolysis. This is about an ionic compound being formed. Okay, so this is rubidium reacting with bromine. So what will rubidium do? Will it gain or lose an electron if it's reacting with bromine? Anyone? What's the answer here? C. Teodoro thinks it's C, and I agree with him. An electron is going to be lost, and you're going to get the Rb plus ion. So well done, Teodoro. All right, now this is, sorry about this. I honestly don't know why everything's lagging so much. Maybe I'll try and find another. I'm using Microsoft Whiteboard. Maybe I'll try and find another whiteboard. If anyone knows of a better one, please give me a shout. But this one is just not working at all. It's just so slaggy. All right, which one's this one? Apparatus used for the extraction of aluminium oxide. What equation represents the reaction taking place at the anode? The anode is the top one, the positively charged one. What takes place at the anode? Anyone? Someone be brave. What takes place at the anode? Ordney thinks it's B. I think it's B. Well done, Ordney. All right. Now, why is it B? If you look at this, anode is positive, so it's got to be a negative ion. So that means, well, that's not an ion, is it? It can't be that. This is a negative ion, but this is a positive ion, so it can't be that. As we all know, aluminium doesn't form Al3 minus, so it can't be that one either. So the answer must be B. Oxide ions go to produce oxygen and 4 electrons. This one is a very nice ionic equation you should learn. Now, what's the consequence of oxygen going to the carbon anode there? Does anyone know? Or can anyone remember? What's the consequence of oxygen being formed at the carbon anode? Consequence. What happens to the carbon anodes? Carbon dioxide is formed, yeah, good. CO2 forms. But what happens to the anodes themselves? Exactly, the anodes lose mass and they start to wear away, and therefore they have to be replaced. Now, for an extra bonus mark, how many days does it take for them to be replaced? I mentioned this in class. I bet no one remembers. The anodes are replaced every how often? No one? All right, you don't have to know this. It's very technical. But they have to be replaced every 21 days. Okay. Anyway, guys, I'm going to call it a day for there. We've done 50 minutes, which is enough. And it's especially enough when we're suffering from so much lag on this. It's really painful. I'm going to try and look for a better whiteboard. For some reason or other, Microsoft just isn't working for us anymore. It used to be fantastic, but I don't know why it's not working these days. Anyway, guys, we'll have a nice day and have, what day is it today? It's Wednesday, isn't it? So I'll see you on Friday, and the next topic is energy changes. That's on Friday. Okay, this topic was from Tabang, and he's not come, which is a bit annoying, but I'll post this on YouTube in like 20 minutes. All right, have a great day. Take care. Bye-bye.